Okay, so we're going to talk about the domains of a few specific types of functions. So specifically in this video, I'm going to talk about how to find the domain of polynomial functions, rational functions, and square root functions. And if you forgot what these are, I will also remind you of what these are. So let's get into it. So first we're going to talk about polynomial functions. So polynomial functions look like this. So you're going to have like a sub n, x to the n, a sub n to the n minus 1 to the x to the n minus 1. This definition I know looks kind of scary, but the idea is basically like you can have whatever number you want here and then whole number, positive whole number exponents. I think a lot of times it's easier just to show you what polynomials are. So when I talk about polynomials, I'm talking about things like this, like f of x equals 2x minus 1, or g of x equals x to the fifth minus 3x squared plus 7, or 4x cubed minus 2x squared plus 5x plus 1. So this is what makes it a polynomial, is that it's some positive whole number exponent, and then you can have whatever numbers you want in front of the x, that's fine. Okay, so that's what a polynomial is. These are absolutely the easiest functions to find the domain of, because the domain of any polynomial function is just all real numbers. Okay, so just remember that. We'll come back to that in a second. Because a good segue to this is rational functions. So rational functions are functions of the form, so you've got this p of x over q of x does not equal 0, and p of x and q of x are both polynomials on top and on bottom. So rational functions are things like, like 3x plus 1 over x squared minus 4, or g of x equals x cubed plus 1 over x squared plus 5x plus 6. So these are what we mean by rational functions. Okay. Now, the domain of a rational function is all real numbers except for any numbers that will make the denominator equal 0. So let's take these two ideas now and put them together in a few examples. So if I ask you just to find the domain, so if I notice that this is a polynomial, which this is a polynomial, then this is actually pretty simple, because then I don't have to really do any work. I just know that the domain is all real numbers. Now, for example B here, so I've got 4 over x plus 2. Okay, so in this case, this is a rational expression, and so what I'm worried about, or it's a rational function, sorry, and so what I'm worried about is where the denominator will equal 0. So what I'm going to do is I'm going to set x plus 2 equal to 0, so I'm going to find the value where this will equal 0. So I probably didn't even need to do this. Like, you could probably just look at this and say, oh, when x equals negative 2, you'll get a 0 in the denominator. But this is the value that I need to exclude. So how do you exclude that? Because we always write domain and range in interval notation. Well, you can visualize this on a number line. So let's pretend here's negative 2. So effectively, like, what's happening here is I want to represent all of these values on the number line except for negative 2. I need this gap here. And so then if I want to write this in interval notation, so starting here, this is negative infinity, and I continue all the way to negative 2, but negative 2 is not included in this interval notation, so it gets a round bracket. Union this again with negative 2 and then continue on to positive infinity. So this is how you effectively like jump over negative 2 in interval notations. This is how you exclude one of those values. Okay. So let's try this again. So I've got just two slightly harder looking examples. I would love if you would pause the video and give this a try yourself just to check in and see how you're understanding this. Remember, math is not a spectator sport. You'll learn best by, actually trying the examples. Okay, so hopefully you wrote something down. If not, I'd seriously suggest you pause. So this first one is a polynomial. So this is going to have all real numbers for its domain, so negative infinity to infinity. Now, D is a little more interesting. If I set the denominator equal to 0, just to figure out which values will make it equal 0, I would factor this. And I would find that at x equals 3 and x equals negative 3, these are the two values that will create a 0 in the denominator. So these are the two values that I need to exclude. So I really like using the number line just to help me visualize how to write my interval notation. So basically, I need to have a whole at -3 and 3, and then otherwise everything else needs to be included. So if I use my number line, this starts at -infinity and goes to -3. We jump over -3. And then from -3, I go to 3. And then from 3, I go to infinity. So it's very common for people to miss the middle part of this. And I think that's just because, like, I get, like, why you would write that, like, without the middle part. But once you see the visual number line, it makes sense why you, like, need this. So if you did not include this middle part, just write the number line. I think that's a really easy fix to kind of wrap your brain around what's happening. Okay, so we have one more type of function to talk about in this video, which is the square root function. So a square root function is really like a function where you have a square root in it, right? So square root of some expression. Okay, so the thing about the domain of a square root function is that this part under the radical has to be positive. And just vocabulary, this part that's under the radical is what's known as the radicand. And yeah, so it has to be positive. So why does it have to be positive? Well, so when we discuss domain and range, we're only considering graphable values. And so if you think about square root functions, so can I take the square root of -4? Yes, I know that the square root of -4 equals 2i. But the issue here is that you can't graph -4 and then, oops, this should say just 2i, sorry. This should just say -4, 2i. So there's no like 2i on the y-axis, so it can't be graphed. So that's why when we talk about the square root function, this just has to be positive, because while yes, I can evaluate this and find imaginary number values, I can't graph them, and so it's got to be discarded for the domain and range. Okay, so let's talk about how this would look then, like in an example. So let's say I've got the square root of x minus 2. So if the goal here is to have x minus 2 be something just positive, I can use inequalities to help me figure that out. So effectively, what I need to have happen is I just need to know all the values where this is going to be greater than 0. So I can solve this inequality to get that this just has to be, x just has to be greater than or equal to 2. So as long as x is greater than or equal to 2, that will be the domain. So this is the condition that needs to hold for finding this domain, but then I have to write this in interval notation. So again, you could always use a number line just to help you visualize this. So here's 2. 2 is included, so it gets a square bracket, and then here's all the values greater than or equal to 2. So in interval notation, this would just go from 2 to infinity. Okay, so let's do that again. I've got the square root of 4x minus 1. So I would love it if you just checked in with yourself to see if you're understanding this. So maybe pause the video here, give this a try, and then hit play when you think you've got it. Okay, so in this case, I want to have this 4x minus 1. I need this to be greater than 0. So what I'm going to do is I'm just going to solve this for x. So first I'll add the 1 over to the other side, and then I'll divide both sides by 4. So as long as x is greater than or equal to 4, the values under the radical will be positive. Okay, so once again, I can use a number line to help me out with this. So here's 1/4. So I need to include 1/4 so it gets a square bracket, and then I go this way. So the domain then, in interval notation, will go from 1/4 to infinity. Okay, so I have one more here, and I'm going to tell you that this has a little bit of a plot twist to it. I'm not going to tell you what the plot twist is. I think this is a great challenge problem just for yourself. So pause here, give this a try. Remember, math is not a spectator sport, and you'll learn more if you try. But also try to figure out what is that plot twist, and then hit play when you think you've got it. Okay, so I need to have this 4 minus x greater than or equal to 0, just like always. So first I'll subtract off the 4. So now I've got negative x is greater than or equal to -4. Okay, here's where the plot twist comes in. So when I divide both sides by -1, so the thing is when you divide by a negative number, this is going to flip, right? So this now is going to say that x is going to be less than or equal to 4. So again, if I use that number line to help me out with this, here's 4. Now I need to go this way. So having that number line is very, very helpful. So then this goes from negative infinity to 4. Because starting here, this is the negative infinity direction on the number line. And then we come all the way up here to 4. Okay, so that's it for this video. So if you found that helpful, consider hitting the like button. If you have any questions, you can always leave me a comment. And I will talk to you guys in another video. Peace.